Hello students, this is a topic test video on the QA topic tests that are available on Bodhee Prep Android app. The idea is once you've gone through the basic concepts of a topic, you refer to these tests to understand whether you're able to do those questions in a test environment or not. With every test, there is a video which gives you the basics, the solutions, and a brief analysis of what would have been a good attempt for a test that was in the exam. uh, in terms of level of difficulty, in terms of time that you should have put in for the test. There are more than 200 such topic tests available on the Bodhee Prep Android app. The link for the app is in the description below, so make sure you download the app and make the most of these tests. This video is on the topic set fill. This is the fourth test that we are discussing. In terms of level of difficulty, probably a moderate level of difficulty test, where if you get 6 questions correct out of overall 10, six net correct. I might attempt 8 or so, I might get 1 or 2 wrong, whatever. Net 6 correct in about 22 minutes will give me a 95 plus percentile. If I look at the questions, the first question says, in a hospital, the blood of 500 patients was tested. It was found that 228 patients had A antigen, 51 had B, 422 had RH antigen, while 35 had none of these. In addition, it was found that 18 had A and B, 41 had B and RH, 193 had A and RH, and 38 in all three. An individual will have A plus blood type if he or she has only A and RH antigens. How many patients had A negative? Oh, sorry, A positive blood. This is a dash. So what we do is we start with making a Venn diagram. Uh, A is 228, B is 51, RH positive or negative is 422. 35 had none of these. So in this Venn diagram, we will have 500 minus 35, which is 465 as the total. 35 will be outside. 18 had A and B. Let us start with all three. 13 had all three. So we write 13 here. 18 had A and B, out of which 13 are here. So 5 will be here. Only A and B. 41 had B and RH. 13 are here. So 28. 41 minus 13 will be only B and RH. 193 is 228. 193 had A and RH. So only A and RH will be 193 minus 13, which is 180. We are looking at A positive, which is A plus A and RH. We are looking at A and RH has only the A and RH. Okay, so it is very clear from here that only A and RH antigen is these 180 people. So A positive will be option C. 180 becomes my answer. In terms of level of difficulty, I'd say easy to moderate, 1.5 to 2 minutes to solve. All we do is make the Venn diagram and get the answer. In a group of 800 persons, 600 can speak English, 400 can speak Telugu. If all people speak at least one of the two languages, how many people can speak exactly one language? 800 people, 600. Okay, so what we can do is rather than drawing the Venn diagram, let us stick to the formula. N of A union B, N of A union B is equal to N of A plus N of B minus N of A intersection B. N of A union B will be the total number of people, 800. N of A will be 600. N of B will be 400 minus N of number of people who speak both languages. 1000 minus 800 is 200. So number of people who speak both languages will come out to 200. How many people can speak exactly one language? Now I draw the Venn diagram. I say English and Telugu. 200 speak both of them, both languages. 600 speak English, 200 here. So 600 minus 400 only English. 400 speak Telugu. Therefore, 400 minus 200, 200 only Telugu. 600 will speak exactly one language. Or there were 800 people. 200 are speaking both languages. So 800 minus 200, 600 will speak exactly one language becomes my answer. In terms of level of difficulty, easy question, not more than a minute and a half to solve. If a total of 150 students, if out of a total of 150 students who read at least one of the newspapers, Times of India, Hindustan Times, Hindu, 65 read Times, 42 read Hindu, 50 read Hindustan Times. What is the maximum number of students who read all the three newspapers? So here we can say X, Y, Z are the number of people who read exactly one, exactly two, or exactly three newspapers respectively. X plus Y plus Z will be the number of people, which is 150. X plus 2Y plus 3Z will be the total number of people counted individually, that is 65 plus 42 plus 50. Therefore, X plus 2Y plus 3Z will come out to 65, 107, 157. Subtracting this from this, we'll get X minus X cancelled, 2Y minus Y is Y, 3Z minus Z is 2Z, which is 7. What can be the maximum possible value of Z? Maximum number of students who read all the three? Clearly, 2Z means this has to be a multiple of 2. So if we put Y as 1 and Z as 3, we'll get the value as 7. So the maximum value that Z can take is 3. 2, 3 are 6 plus 7, so 3 becomes my answer. In terms of level of difficulty, I'd say a moderate sort of level of difficulty, about 2 minutes to solve. In a group, if 60% of people drink tea, 70% drink coffee. What is the maximum percent of people drinking either tea or coffee, but not both? So basically what this says is, we're looking at tea, we're looking at coffee. Now, number of people with T union C would be number of people drinking tea plus number of people drinking coffee minus number of people drinking tea and coffee, both T intersection C. This we know is 60, this we know is 70. If we put this as 100, we will get the value of this T intersection coffee as 30. 60 plus 70 minus 100. In that case, we will have tea was 60 people, so 30 minus 60 or 30. Coffee was 70, 30 minus 40. In this case, number of people drinking either tea or coffee, but not both, will be 40 plus 30, which is 70. The other extreme case will be where we do the complete overlap of people drinking tea and coffee. Since this is a smaller number, we say 60 people drink both tea and coffee, and therefore only tea becomes 0, only coffee becomes 10. 60 minus 60, 70 minus 60. In this case, number of people drinking either tea or coffee but not both is only 10. This becomes the maximum value, this becomes the minimum value. So since we are looking for maximum, my answer is option B, 70%. That becomes the thing. Overall, in terms of level of difficulty, easy question because there are only two sets, not more than a minute and a half or 2 minutes to solve. So for the next three questions, it says, help distress. HD is an NGO involved in providing assistance to people suffering from natural disasters. Currently, it has 37 volunteers. They are involved in three projects: tsunami relief, flood relief, and earthquake relief in Gujarat, Tamil Nadu, Maharashtra. Each volunteer working with Helpdesk has to be involved in at least one of the projects. So if we draw a Venn diagram, which says tsunami relief in Tamil Nadu, flood relief in Maharashtra, earthquake relief in Gujarat. These are the projects. Everyone is involved here. Maximum number of volunteers are in FR. Among them, the number of volunteers in FR alone is equal. So this value is equal to volunteers having additional involvement in ER. The sum of these two is equal to this. The number of volunteers involved in ER project alone is double the number of volunteers involved in all three. So if all 3 is X, ER alone is 2X. This has been used. TR is equal to 17. 17 volunteers are in TR. Number of volunteers in TR alone is 1 less than number of volunteers in ER alone. So this is 2X minus 1. 10 volunteers involved in TR project are also involved at least. So basically the sum of these 3 values is 10. Suppose this is Y, this is Z. Y plus X plus Z is 10. So we can say 2X minus Y is equal to 7 because this entire circle is 17, which means 2X minus 1 is equal to 7. Sorry, or 2X is equal to 8. X is equal to 4. So from here we get the value of X as 4. I will substitute this in the required places. 2X minus 1 becomes 4 minus 1, 7. This becomes 8, 2X, and this becomes 4. Next, X plus Y plus Z is 10. So we know Y plus Z is equal to 6. This is one equation that we have. 10. This has been used. At least one more project. Let us use the second, but among them, among the FR people, the number of volunteers involved in FR project alone is equal to the number of volunteers having additional involvement in ER project. So if this is now, say if this is A, this will be 4 plus A. Involvement in FR alone is equal to involvement in FR and additionally ER. Now, if you look at the total, TR is 17 plus these 3. 4 plus A plus A plus 8. This should be equal to total number of people 37. So 2A will be 20 minus 8. A will be 4. Let us put A as 4. This was 4 plus A 8. This becomes 4. We have Y and Z still with us. Now let us look at this information which says maximum number of people in FR. FR is nothing but 844. 8 plus 4 plus 4 is 16. 16 plus Y is greater than TR. So Y is greater than 1. Secondly, 16 plus Y is also greater than this number 844. 16 plus Z. So Y is greater than Z. We have these two inequalities as well. It says the minimum number of volunteers involved in both FR and TR, minimum, but not in ER, will be how much? It is 16, 20, 20, 31. Y plus Z has to be equal to 6. Y is great. Let us look at the solutions for Y and Z. Y is greater than Z, so Y could be minimum 4, Z could be 2, Y could be 5, Z could be 1, Y could be 6, Z could be 0. These are the 3 solutions possible. Because Y plus Z has to be 6, Y is greater than 1. At least 2, but Y is also greater than Z. So Y will be more than half of 6, which is 3. So Y is 4, 2, 5, 1, 6, 0. We have to find the minimum number of volunteers in FR, TR both, but not in ER. FR, TR both, not in ER is actually Y. Minimum value of Y is 4. That becomes my answer, option C. Again, in terms of level of difficulty, I'd say this calculation might take almost 2.5 to 3 minutes. Moderate to difficult level of question. Basis this, we'll move on to the next question, which is question number 6. Just removing this part. Now the question 6 says, which of the following additional information would enable us to find exact number of volunteers involved in various projects? Y and Z is something that we do not know. A says 20 volunteers are involved in FR. We know FR, if we know FR, 8, 4, 16, Y will be 4. This can be helpful. 4 volunteers involved in all 3 projects. We already have this number. 23 volunteers are involved in exactly one project, 8 plus 8, 6 to 7. We already have this number. No need for any further information. We have three cases for Y and Z. If we have information A, we will know 20 volunteers are in FR. FR has 8 plus 4 plus 4 plus Y. Equating it to 20 will give us a value of Y and therefore a value of Z. So answer for this becomes A. In terms of level of difficulty, again, the solution has been done. Not more than a minute and a half to solve. Moderate level of difficulty. Moving on to question number 7 then. What we do here is removing the okay, so I'm erasing the part that will not be required probably, the calculation part for the seventh question, and we'll just focus on the information that we had. So we had three circles for TR. Just looking at the information again. So the circles that we had were TR, which is 17, FR, which is maximum, and ER. The numbers were 4, 4, 8, 8, 7, Z and Y. Y and Z, we know we'll take these values, so erasing the other parts. Now what the question says, or additional information question 7 says is, after some of the volunteers were involved in all three projects were asked to withdraw from one project. As a result, one of the volunteers opted out of TR. The person who moves out of TR will go to FR and ER only, so this will become 5. One opted out of ER. The person who leaves ER will get added here. 2 people are gone, so 2 are left here. Remaining ones opted out of FR. So this will become 0. 2 people will come here. This will now become 2 plus Z. Which was following statement is necessarily true. So let us now find out the total for TR, FR and ER. TR total will now be 7 plus 8 plus Y plus Z plus 2. So this is no longer Z plus 2. So 7, 8, 9, 10 plus Z plus Y. Z plus Y is 6, so 16. FR will be 5, 8, 13. 14 plus Y. ER will be 8 plus 5, 13, 14, 15. 15 plus Z. Lowest number is for TR. If Y or Z is 0, ER will be 15. That will be the lowest number. So this is not necessarily true. More volunteers now in FR than ER. FR minimum will have 14 plus 4, 18. In which case ER will have 17. FR will have minimum of 18 when Y is 4. ER will have a maximum of 17 when Z is 2. So yes, FR will always be more than ER. More volunteers in TR as compared to ER. Again, it depends. If ER is 2, Z is 2, this will be 17, this is 16, TR will be lesser. So this is not necessarily true. Definitely B will always be true. In terms of level of difficulty, again, I'll say moderate to difficult because there are cases here about 2 minutes to solve. 4 types of biscuits ABCD. 10 children like all 3 ABC. 15 like all 3 BCD. 40 like A. 95 like B. 75 like C. 55 D. 70 like exactly 1. Those who like A do not like D. Now, if we make groups of 3, we can have A, B, C. This is given as 15, 10. We could have A, B, D. This is 0 because someone who likes A does not like D. A, C, D. Again, this will be 0. B, C, D. This is given as 15. So number of people who like 3 could be 10 and 15. Also, A, B, C, D will be 0. Because someone who likes A does not like this. So we can say that number of people who like A, B, C only is 10. Number of people who like B, C, D only is 15. Also, if X, Y, Z, A are the number of people who like 1, exactly 2, exactly 3, exactly 4 biscuits, exactly 1 biscuits is given as 70 like exactly 1. This is what we have to find out. How many children get exactly 2? Number of people who like exactly 3 biscuits will be A, B, C and B, C, D. This is 25. This is 0 because no one can like all 4 biscuits. So I can say X plus 2Y plus 3Z plus 4A is equal to A plus B plus C plus D. So X is 70 plus 2Y plus 3 into 25 plus 0 is equal to 95, 75, 170, 265. 70 plus 145, so 2Y becomes 120 or Y becomes 60. How many children like exactly 2 biscuits? 60 children like exactly 2 biscuits becomes my answer. In terms of level of difficulty, I'll say moderate to difficult. There can always be a urge to go with the Venn diagram, but that will make things more difficult. Writing the equation is an easier method. 90% of the students of the class passed in physics, 95% passed in maths. 1% failed in both. How much percent passed in both the tests? Let us look at passed in physics, passed in maths. 1% failed in both, so 1 will be here. This sum has to be 99. 90% passed in physics, 95 in math. So I can say n of p union m will be n of p plus n of m minus n of p intersection m. These are people who have passed. This will be 99 because 1% failed in both, so 99 would have passed in at least one. This is physics. 90 plus 95 minus 95 minus n of p intersection n. 185 minus 99. N of p intersection m therefore will be 86. If this is 86, this will be 4. 95. This will be 9. Overall 93. So how much percent passed in both? 86 becomes my answer. Again, in terms of level of difficulty, I'd say easy to moderate, less than 2 minutes to solve. In an examination, 49% students failed in chemistry, 36 failed in physics, 15% failed in both physics, chemistry. We are drawing a Venn diagram for people who passed. Therefore, 15 will be outside. They failed in both. There have to be 85% people in the Venn diagram overall of past students. 49% failed in chemistry. When I look at people who failed in chemistry, 15 is here. So the remaining should be in this box, which passed only in physics. So 49 minus 15. 34 would have passed only in physics. Therefore, 34 and 15, 49 would have failed in chemistry. 36 failed in physics. They will be outside this box. So 15 are already there. So 36 minus 15, 21. 21 would have passed only in chemistry. 21 plus 15 failed in physics, 36. 49. 34 and 49 failed in chemistry, 49. 15 failed in both, they're already outside. Therefore, if I look at this number who passed in both, I can say 34 plus x plus 21 is equal to 85. 55. X becomes 30. Therefore, 30% people would have passed in both. which means 51% passed in chemistry, 49 failed in chemistry, 64% passed in physics, 36 failed in physics. Now the question is the total number of students who pass in chemistry alone? We know that chemistry alone is 21%. So 21% of number of students would be 630. So 21 upon 100 into n is 630. 21 threes are, so n becomes 3000. Number of students is 3000 becomes my answer. Again, in terms of level of difficulty, I'd say moderate, about 2 minutes to solve. Overall test, if I look at 6 questions in about 20 to 22 minutes, my 6 questions would be 1, 2, 3, 4, 8, and 10. Which are these? Doing this, just drawing the Venn diagram gave me the answer. So attempting this question. This was, I think, an easy question amongst the overall 10 questions. Would have done this as well. Basic application of the equation will give me the answer. This also, I think, was a doable question. I am not counting 5, 6, 7 as definite questions because when the numbers change, we might not be able to attempt them. This, I think, was a doable question. Again, the idea has to be whether we go with the Venn diagram or the equation is the question is what we have to choose. Again, out of 9 and 10, you would have looked at one. Both are similar questions. If I know how to do the one question, I will be able to do the second. So 1, 2, 3, 4, 8, definitely one of 9 and 10 can be chosen.